Alright, so this is just going to be a brief overview of 5-5 through 5-6. 5-5 is inequalities in one triangle, 5-6 is inequalities in two triangles. So first off, for 5-5, for three sides to even make a triangle, three things have to be true. So do these sides form a triangle? Okay, so if I give you, say, 3, 4, and 5, if I add any two sides together, they have to be bigger than the third. Okay, so if you need that visual, we can always draw a triangle over here. So if I add two sides, I'm going to add these two first. So 3 plus 4, it has to be bigger than the third side. Okay, if I choose two other ones, so let's say 4 and 5. So 4 plus 5, it has to be bigger than the third side. If I add two other sides, so let's say, which one haven't I done yet? 3 and 5. So 3 plus 5, it has to be bigger than the third side. So see if that's true. 3 plus 4 is 7. 7 is bigger than 5. We're good. 4 plus 5 is 9. 9 is bigger than 3. We're good. 3 plus 5 is 8. 8 is bigger than 4. We're good. So these would make a triangle. So yes, this makes a triangle. Okay. Let me give you one that maybe, let's see. Let's do 4, 7, and 11. Okay. So with these, I'm going to take any two sides, add to see if it's bigger than the third. So I have 4 plus 7 has to be bigger than 11. 4 plus 11 has to be bigger than 7. And 7 plus 11 has to be bigger than 4. So let's go through this. 4 plus 7 is 11. 11 is not bigger than 11. So that's no. Even though these two things are true, that first one's not. So do these three sides make a triangle? No. Okay? Now, you can find a range of a third side. So if you're given two sides of a triangle and we want to find the range of the third side of a triangle. Find the range of the third side of a triangle. Okay, so if I give you that the let's do 9 and 15. So there's two of our sides. Okay, we want a range, which means x is bigger than one number and smaller than a number. So I know I need to fill in these two areas. To get the smallest possible number that x or the third side could be, we're going to subtract these two numbers. So 15 minus 9. To get the biggest possible value that x could be, we're going to add these two numbers. Okay, and fill that in. So for this example, if one side's 9 and one side's 15, x could be anything that's bigger than 6 and smaller than 24 to make a triangle. So subtract to get the smallest, add to get the biggest. Now, with inequalities, we can compare our sides and angles. So when you have a triangle, I'm going to do two here. On this first one, if these are my sides, my biggest angle is across from my biggest side. Okay, so I'm going to list biggest angle to smallest angle. Okay, so my biggest side is 15. So I'm going to go directly across from it. Oh, let me label the triangle. Okay, so I'm going to go directly across from it. And that means my biggest angle is angle K. What's my middle or my medium side? My middle side would be 13. That's the next biggest number. So now I can go across from 13, and my middle angle would be angle B. And then do it again. Your smallest angle, or smallest side, would be 12. So we're going to go directly across from it, and my smallest angle would be angle L. Okay? The exact same rules apply when you're given the angles. So in this next triangle, I'm going to give you, let's do 60, 80, and 40. Okay, now remember, sometimes you're going to have to find that third angle. Remember, all three angles in a triangle add to be 180. So now we're going to do sides from smallest to biggest. Okay, we'll label our triangle. All right, so my smallest to biggest. My smallest angle is 40. So we go across from it, and my smallest side is XW. Okay, my medium side, my middle side, let's see, my middle angle is 60, which means I go across from it, and my middle side would be WQ. And then for the last one, my biggest angle, my only angle left, if I go across from it, the next side, the biggest side, would be XQ. So smallest, middle, biggest. Okay? Now that works exactly the same when you have two triangles, except then you're comparing the angles and sides in two triangles. So if I have this triangle, it's a terrible triangle. If I have this triangle and this triangle, and I give you that this is 35, here's 18, 7, we'll do 55, and 21, and 6. We'll do A, B, C, D, E, F. Okay, so now if we're going to compare the angles and sides in these two triangles, we're going to figure out which ones are bigger and smaller. All right, so if I want to compare, let's do angle B to angle D. Then we'll do DF to BC. Okay, so we're going to do the same thing. Now it gives us angle B is right here. So I'm going to go across from him, and he's across from a side length of 18. He's not equal to 18, he's just across from the side length of 18. Now look at your other triangle. I want to look at D. D is right here. So if I go across from him, he's across from a side length of 21. So which angle is going to be bigger? The angle that's bigger is across from the bigger side. So angle D would be bigger. So have your alligator eat angle D. Okay, the same thing works with the next one. So DF would be this guy right here. Well, what angle is he across from? DF is across from angle 55. Now we want to look at BC. BC is this guy in pink. So if I go across from him, what angle is he across from? He's across from 35. So which side is going to be bigger? The side across from the bigger angle. Okay? Now those only get tricky when you have triangles where you have to actually solve for missing side lengths. So if I have this crazy figure, okay, and I give you that this is 95, 35, 40, 50. Okay, it doesn't give us all the information. LMNO. So we're going to compare some sides on this one. Okay. Now I want to know if MN to LO. Then I want to know ML to MO. Okay, so when we have a triangle where we don't have all the angles, you might have to find the angles. How do we find the angles in a triangle? Well, we have a couple different methods, okay? We know that 3 angles in a triangle add to be 180. We also know anytime we have a straight line that's split up, these 2 angles would also add to 180. So you want to look for those 2 things. Now this figure up here does not have any straight lines in it, so we're going to have to use our 180 rule for each of the little triangles. So I'm going to grab a calculator, okay, and we're going to subtract from 180. So we have 180 minus 95 minus 35 leaves us with this guy down here is 50. Okay, and I'll write what I did so that you guys have it. Then I'm going to do it in the other triangle. Okay, so exact same thing. 180 minus 50 minus 40 leaves me with 90 down here. So now compare your sides again. So the first one I want to look at is MN. MN is this side. Well, what angle is he across from? He's across from 50. Then we're going to look at LO. LO is this guy. Well, who's he across from? He's on this left triangle, and he's across from 35. So who would be bigger? The guy with the bigger angle. So MN would be bigger. Do we know what MN equals? No. We just know he'd be bigger because he's across from the bigger angle. Same thing with the next one. So on the next one, we're comparing ML, which is this guy, and he's across from an angle of 50. And then we're going to compare him to MO. Now MO could be in either triangle, but we already have the triangle from the left, so we're going to compare it to the triangle on the right, which is across from 90. Okay, so which one's bigger? The side across from 90. Okay, so that's kind of how the inequalities work. That's how you can find the range of a third side, and that's how you can tell if 2 sides add, or what am I trying to say? If 3 sides make a triangle. Okay, let me know if you have any other questions.